So let's get cracking. IMF, what is it? So my first little bit is really just to tell you what the verbs and nouns are, so that when you ask the questions, you can ask them using the right words. So IMF was created because of a simple manufacturing problem. You've got some stuff, you're trying to get it to a number of destination places where there are eyeballs. You need to manufacture a specific version, and there's all these kinds of intermediates you've got to get through. So how do I get the stuff I've got to the places that I want to go to efficiently? So that's the problem space that IMF lives in. It's also a delivery problem, because despite the best efforts of the English and the Spanish and the Portuguese and the Dutch back in 1600, the world will insist on speaking their own language. We've not standardized on English yet, we've not standardized on Spanish, and people insist on writing using different languages as well. It's a real pain because you've got to make all these different versions of your content for that native audience. So IMF lives in this space as well. But it also lives in the compliance space. When you deliver a movie to each of the states in the US, not all the states have the same laws regarding swearing and nudity, so actually you have to edit for compliance at a state level and at a country level. IMF lives in that space as well. But it's also a content creation problem, that if you're actually trying to put all of this stuff together at the last moment and trying to get it to somewhere where it's going to air very quickly, you don't want to have to render a 3 terabyte file right at the last minute. Wouldn't it be nice to just do the last little slug and put it in? So this whole, how do I publish the stuff I've got in an efficient, bandwidth efficient, storage efficient way, that's the problem space that IMF tries to live in. So we're mastering for different content owners, for different timelines, for different reasons, different resolutions, aspect ratios, all that randomness that takes place. This is the problem space that IMF lives in, and we're trying to create a standard, international standard, where everybody plays by the same rules to try and make things more efficient. These are just words. The slides will be available later on. I must have given this 1,000 times, so these slides will be published. So how do we do this? We do it with components. So instead of rendering a 1 terabyte video and audio interleaved with metadata and posters glued on the end, we split the program, the content you're trying to deliver, into components. We put the video in the video files, we put the audio in the audio files, and we glue it all together with some other metadata. That's basically what we're trying to do. So the words you need to know are these. The first word is the composition. The composition defines the version of a title. Okay, that's all it is. It's a small XML metadata file. It's just metadata that says this is the title, this is how all the bits go together. If you like, that's your recipe. The next bit is then, we might have several versions. We've got the master version, but there might be one for France and Germany and Spain and Japan. So each of those is represented with the same sort of file, these CPLs. Okay, so we've got different versions of our title now. Let's put those in the bucket. But then we've got to have some actual stuff. We need some video, for example. So for each segment, each clip of video, we've got a separate video file. That's good. And for each one of the audio tracks or audio inserts, we've got a separate audio file. It's one thing per file. We need subtitles as well. So for each thing, that goes in a file of its own stuff. And it's all wrapped in MXF. It's all wrapped the same way. Anything that goes in a timeline gets wrapped in MXF, because we need to know how the timing model of your media maps to the timing model of the composition. So all of that messiness of putting the right thing at the right place at the right time, that's all done with the MXF timing model. We put all of that in our bucket. So now we've got a bucket of stuff that represents lots of versions of our program. Now I need to deliver it to someone. So to deliver it, we put it in a package. There we go, we put my bucket in my package. But we need to know what's in that package, because IMF wants to be secure. So we need a packing list, which is just a list of the stuff that you put in your package. But there's a couple of sneaks to IMF. We don't use things like file names, because those are evil, because people edit them, and we lose things when you allow people to edit stuff. So we need to somehow map the file names to the magic identifiers that are in IMF, and that's what the asset map does. It maps identifiers to the file names of those assets. And there's other stuff. You might want to put in some poster art or a script or a QC report. And so we've got this extra thing called a sidecar map, which allows you to put this extra stuff into your package. So once you've got all that in your package, you can then deliver it to someone. So now we've got these components. We've delivered them to you, and they represent a version of our title. You might have heard a thing about apps. What are these apps? What's an app to? Well, an app really just constrains how the video and audio is represented. And in fact, we've not deviated much in terms of audio, so really apps are really just controlling what the video codec is. So I talked about compositions. The compositions reference the media, and we've got these things called markers, which allow you to put little bits of metadata along the timeline. We've talked about the media. These are called track files, so I just want to introduce the word track file. The track file is so called because it's the media for a track. We don't have track numbers, we don't number them 1, 2, and 3, because if we call them 1, 2, and 3, people assume that the order has importance. But in IMF, we don't use track order for importance, we use metadata. So everything is described in metadata. The main point about these slides is that the composition is king. Use it in an email today. Those of you who really get excited by standards will love this slide, because IMF actually, like the thing it describes, is split up into a lot of components. We constrain MXF, we take a whole bunch of goodness from digital cinema, we constrain all of that, and we describe all the different apps for the different codecs. But we've introduced some extra things like high dynamic range is appropriate for each and every one of the codecs. So let's put that in a slightly different axis. So we've got the very sexily entitled dynamic metadata for color volume transformation, which just slips off the tongue. That's how we describe HDR within IMF. And then we've got the immersive audio plugin, or IAB, the immersive audio bitstream, which describes how you put things like Atmos and DTSX and MPEG-H inside IMF. And then, once you take this mastering package, you probably want to render it into some sort of deliverable for your origin service for your OTT, or your play-out service for your broadcast. And that's where a thing called the output profile list comes in, which says, hey, you take this stuff that you described in IMF and turn it into a bunch of MPEG dash deliverables, for example. And that's the output profile list, which internally has a bunch of macros. And of course, we've got metadata like the SIMPI registers. Very, very quickly, you can think of it a bit like the food analogy, which is, for food, you've got Walmart. For IMF, you've got a data center. Your delivery package is basically just a list of stuff that you've got, or you need to get. Your recipe for how to make the thing, well, that's your CPL. And then the shape of the thing that you're going to make, well, that's the OPL and some other configs that go into your big transcoder. And your final delivery will be the right version of your content in the right place at the right time. And that's the problem that IMF is trying to solve with all of the complexity that we have today. There is no time code in IMF. Anyone found using time code in IMF will be stung with a cattle prod. But we synchronize because we have a very good timing model within MXF. MXF hasn't used timecode for the last 20 years, yet somehow timecode still exists in the industry, and everything still gets out on air synchronous. So don't be afraid of the fact there's no timecode. There's no file names, how can we find stuff? Anybody here use email? At the back end of your email server, they don't use file names either, and your email is super reliable. Oh, let's not go there. So we don't use file names, but there are tools and techniques that allow MAMs to manage your stuff at massive scales that no human could ever manage. So that was my run through what IMF is, what the words are. Hopefully by the end of the day, all of those words will be super slick and understandable for you. So first I'd like to introduce from Fraunhofer, Matthias Reim, who will tell us about Fraunhofer's work in IMF. Thank you very much, Matthias.
Thank you very much. So, what do I have to press to get the video started?
You just smile at Tim and Tim will make it do magic, make it happen.
Okay. And I'll wait for the magic.
Just putting the coin in the meter now.
Yeah, our software is called EasyDCP. It comes in two flavors, the creator who has guessed it already on the creation side and the player on the playback side. And here we can see a little bit dark. It's a bit dark on the projector, but we'll get through it anyways. So we want to create an IMF, and we, as Bruce told us about, have track files, and they come with certain properties, for example, color spaces. And we don't want to arrange it every time for every track file, so we just set color spaces and subsampling and the aspect ratio, just all preset for everything we import. And that saves us a lot of work later, so we just get in a few track files for the homework we were given prior to this event. And yeah, in the end, it will be 2 video track files and some black frames in between to separate them. And here we see how we can just import 5.1 audio easily and some stereo input as well. There we go. And so basically everything you do in EasyDCP is just meant to be as easy as the name suggests. So we just drag the first thing on the timeline for it and the second one right beside, so it snaps together. And in the top half you can see basically the same as the timeline, just for basically DCP creation, which had the reel. So it's the thing we're phasing out by now. So don't get too confused. The important part is the timeline on the lower part. And with a little sliding of the mouse, we have the picture, the sound, and even Dolby Vision metadata on the timeline, and can prepare the IMF. So the XML for first intro, and then a short look at how the IMF should look like. And that's just a few clicks away. So we'll just append and prepend the black frames. This can be done simply with this small dialog. So we'll append 1 second as required. And it will automatically be inserted, even with some dummy metadata for Dolby Vision. For black frames, that's very simple. And the same at the start to fulfill the requirements from our homework. But now we have this missing silence audio that was required for stereo and for 5.1 audio. And we will just generate one on the fly. And the same can be done for both. It's just simple. Select how many frames you want of silent audio, and it will just generate a dummy track file on the fly. We'll do the same for the others. 1 second on 1 second part, and the same for 4 seconds. And it's almost done by now. And we could recycle the same silent audio track files as well, but just for, as an introduction, you can generate as many as you need and just put them at the right places and they will snap right in. And there we go. But wait, there was something more. We have to do something at the end, the black frames, as can be seen on the right side. So we will just do that on a whim. And since it knows how the project has looked by now, we'll just append everything at once. The dummy sound and the dummy metadata for Dolby Vision. So, and since IMF requires to have language set for soundtracks as well, we'll just put in some dummy language metadata, and now we're almost done. So that's the project created. nice and simply, just the way it was required. And then we hit generate, get warning that the generated dummy metadata might not be as intended, but it's just a warning. We can select a nice name, the one according to compliance rules will be chosen, frame rate of bitrate of our liking, and then just a short summary. We can check if it works, and then we're good to go. And that's basically IMF creation in EasyDCP Creator. But we also want to validate that our IMF is according to standards, and for that Netflix came up with photon validation, and we just integrated that into our tools, so no command line action required, just load your IMF and you're ready to go. That's the part now. We just call photon just as you would from a command line, so it will be just a little bit more comfortable. And in the end you can see our IMF, we just loaded, will show no errors or warnings, just as it's meant to be. But we don't stop there, since our product is in the market for more than 10 years by now. We already have our own validation stuff in place. So for authenticity, common practices and compliance, as well as integrity checks, there's a lot of stuff you can choose to your liking. And subtitles are also covered. And since it's a grown product, we usually include every feedback we get from customers for special cases and check for them as well. So right now, the JPEG 2000 code streams will be checked, which of course takes a lot of time, but of course every single frame will be checked. So we fast forward a bit. And then there will be some other tests going on as well for audio later on. And some of you might have seen we also check for the bitrate. That can be important for certain old cinema servers. Yeah, and once everything is done, we get a nice HTML report file with all the information about the packages we just validated. And also, as I mentioned, bitrate analysis, so we can see if we are all inside the specs. We just selected, and if everything went right, we get the green light. And it's usually a feature our customers really like, because they just can send the HTML file along the package, and the other side knows it's gone well. But now we want to export stuff from IMFs, since that's also a workflow we experience a lot. So we just load another IMF, can step through it on the player side, and will soon be able to export stuff as much as we like. As you can see, the photon validation and our validation is also accessible here. So no matter which tool you use, you can always look inside the IMF if it's all according to your plans and specs. So here we can see the vast options of export available: QuickTime, MOV files, EPX, TIFF, J2C, whatever you like. And of course, Apple ProRes as well, since that seems to be a fan favorite these days. And you can always check if the options you choose are according to plan. Same for audio, if you want to just get multi-channel wave or QuickTime and MOV, that's all accessible here as well. Another summary, and the export summary for command line at the lower part. If you want to automate it and have workflows that are recurring, you can just generate it once by hand and just go from there on a regular basis. And if you use something else than a Mac Mini, you can also do it a little bit faster. So. And there we go. If you want to, you can look at the results, but since there was no error, it's basically done. And for more information, just visit EasyDCP.com or our booth in Hall 8, booth 80. Thank you.
Thank you, Matthias. So next up is Aaron from OwnZones, who will be giving us a cloudy presentation.
Hey guys, as you can tell, voice is going. Recorded this video about a month ago and I have no idea what's going to happen here, so this is going to be fun. OwnZones is a cloud-based company, so we've taken a pretty different approach to IMF and distribution and media logistics. You could think of us really more like the Google Apps or a cloud approach to doing things, so everything's done in a browser, and multiple people around the world can work on these things at the same time. So if we want to play the video, we'll walk you guys through 3 or 4 different ways that we can build IMFs. This is running in a browser. I'm going into my asset library. The first way I'm going to make an IMF is I'm actually going to go and I'm going to make a CPL, composition playlist. I've already got the essences, those track files have already been loaded, so maybe the package came from EasyDCP or Delete or one of the other products. Maybe they came in from a third party. Oh, I can hear myself. So inside the browser here, I'm going to give my CPL a file name, and then I'm going to go and start finding the tracks out of my library. And so in the cloud there, in your S3 bucket, you can have all your tracks sitting there. Different vendors can be putting them into the cloud. And I'm going to go through, I'm going to create the image track, which is that first video track that we need. All IMFs have to have a video track. I'm going through my library and I'm going to select one. The next thing that I'm going to do is I'm going to add the audio track. And when I hit save on it, what you'll see is the screen will refresh. And in the background in the cloud, we run hundreds and hundreds of machines at the same time. We actually regenerate a preview for you in the browser, and you can see it frame accurate instantaneously. And we can do it with the ACES packages, which is the EXRs. We can do it with ProRes, with J2K, and with Dolby Vision and all the different specs and formats. Because we're running in a browser, though, what we're showing you is not calibrated. So it's still a good idea sometimes to download it and put it on a calibrated monitor if you're doing Netflix deliveries with Dolby Vision. What you would have just seen there when I hit save is it rendered it and I created my very first IMF. The next thing I want to do, as Bruce was saying, is I might want to package it up and put it in that box and send it to somebody. And so I go and I create a package. I'm creating an IMF package in this case. I select my CPL. You watch how quick I say go, and it's generated me the packing list, the asset map, and all those other things it needed. Took all those file name references that are in the MAM. It actually generated the whole package for me like that. So I just stuck it in the box, generated all those things I need. My package is actually ready to start QCing or sending it to somebody. Next thing we're going to do is actually go in here, I'm trying to remember what we did. Open the package, I think. Find it, open it. So all the packages you create and send all around the world are all kept in one place. You keep a history of them. I'm going to go and I'm now going to create a Spanish version because we want to localize and we want to send out my second version. And so I took my English version, I'm changing the title, I'm just grabbing that language track and I'm switching it out for a Spanish version. And I'm adding a caption file, so IMSC1, a time text file. Add that track, grab Spanish or maybe this is Romanian, I'm not sure. But grab the other track, hit save, play, it's Romanian. And now I've got my supplemental version that I'm sending out to my other country, right? Going to go in my packager, and this time I'm going to make a package again, but I'm going to reference the base package, which was that English version. And when we go through and we create the package, you'll notice, and I'm going pretty damn fast, I'm going to select that Spanish CPL, and it's only going to grab the bits that it needs for that supplemental because it references the base. So if you're sending it to 25, 30 different languages, you send the base, and then each version you send is just the differences in the supplemental packages. And so in this case, these files that are referenced here are just the differences that it needs. So it's an incremental package. It's not another full copy of the base and the supplemental. We have this QC workbench that allows you to go in and review it, and you can actually annotate it with other people at the same time. And all the annotations come into the CPL. So you can do like reviews, legal reviews, feedback, advertising customers use it like that. I'm sending it here to Photon, so just like the EasyDCP guys. We also support Quasar, which are the guys at the end, and also Baton. And so in the cloud, you basically grab your package and say send it to Photon, send it to Quasar, send it to Baton, and the the logs will come up inside the browser here, and it all happens in the cloud. And it runs for minutes or hours, depending on how big the package is. And inside the package, you'll have all of those QC reports to go and review, just like you saw with EasyDCP. The other thing that I just did there was I can also deliver it to somewhere. So I can find the package and say, send it to Netflix. We're integrated into the API. And I actually send it through the backlog. Or if I want to send it to somewhere which is a flat package, I can do that by saying send it to Comcast or send it to Hulu or someone. It will flatten it out into ProRes or, MPEG or whatever it needs to do. This is the second way to create a package, which is to create one from ProRes. And so this is Meridian, and we've opened it up, and I'm playing it. You'll see that it's got a bunch of different sound fields. This is ProRes. So the system's inspected the ProRes, and what I'm going to do, the second way we create IMFs, and it's very common, is you'll take a real good 444 quality ProRes, and you'll actually extract all the essences out of it into those tracks and pieces. So I'm going through the extractor here, coming up with the file names, and I'm sampling, and what this is doing is it's allowing me to remix my channels, because you've got those ProRes sitting around, and they've got all these different channel layouts, but when you want to send it to, say, a Netflix, or send it, to a downstream like a Fox or someone that wants IMF, you might need to adhere to their spec. And so you can actually isolate all the channels, remix them in here, and make those different MXFs that you want for those different CPLs, for those different deliveries and versions, right? And so what I'm doing is I'm going through all those different samples, assigning them to those MXFs, putting the Dolby Vision metadata in, and the little thing at the bottom allows me to say I want J2K, I want ProRes, I need black in it, my frame rates, my lossless, all those different profiles and transcode settings that you're familiar with in your typical tools that you use today. And when I say go, hundreds of machines wake up in the cloud, and they do it in minutes or seconds, just depending on how big it is and the density of the video and stuff like that. Everything's spot instance based, and you only pay for the time that you use. So, the software doesn't actually cost any money. You just pay for it as you use it. The other thing that I'm going to do here is walk through. We also can take image sequences. So, you have your cameras, you're shooting DPX or TIFF. You grab the image sequences and you can build them. And this is another way to build IMFs, which is something we call frame DNA, where you can actually compare video. So maybe you've got half a dozen versions of ProRes. And the cool thing about IMF is it's component-based, and so this is actually running through a tool, comparing all the ProReses with each other, and because we have all that compute in the cloud, we're going to make an OV, and then all the supplementals with just the differences. And so in this case, I compared 5 different trailers, and out of those trailers, I came up with one OV CPL, the master, and I came up with 4 what we call supplementals. And I'm going to flick out of this screen in just a second, so it's showing the differences, right, in the video. And you want to get rid of all of the purple there, you want to get rid of it because it's duplication. So your library is, petabytes, we take it down to a petabyte or something, right? With IMF, because we're reducing all the duplicate frames inside your enterprise. So when I hit create CPL here, you'll see the screen that will hopefully come up if I remember doing this. Which will allow you to go into the CPL view and actually toggle between all these different pieces of video that you pulled out of the file. So I'll open that up here, I think. Here we go. So this is one CPL, but you see we're using segment markers that Bruce mentioned, where you can talk about different pieces on the non-timeline time code. And then on the left-hand side here are all the different segments that are extracted, that are the similarities and the differences across all of those versions. And what I'm going to do in here is I'm going to go and say, I'm going to take an English trailer and I want to make it Spanish. I'm going to grab the Spanish overlays. I'm going to flip the audio track, change the caption file, save it as Spanish, and in a couple of minutes, I've localized my first trailer, right? And by doing that, by extracting all that video out of those ProRes. And so you'll see here I'm going and I'm saying replace, grab the Spanish version, change the IDEM out, and you'll see the timeline as I do it. You see those little chunks are changing on the timeline? It's taking that one track and it's putting the segments on top of them in the CPL. And so, put the Spanish audio in, make it a Spanish name, and hit save. Clusters in the cloud wake up, that yellow box, as soon as it disappears, the cluster has regenerated the new rendered version. So now it doesn't have the ident in it. And as I play through it, you'll notice that all of the inserts that come up are all in Spanish and not in English, and this is now my Spanish version that I can package up and send off to that distribution point, right? There we go, Spanish. So localization, compliance, all these sorts of things that generate all those versions. That's the whole thing about IMF, right? Just trying to get rid of all those things and consolidate it all. Up on the top right, there's a little green box. All the time that you're working in our system, if there's anything wrong with the CPL, and some great work that Dan and the IMF user group have done, we validate real time all the time. So if you forget a tag, or you put the wrong bitrate in, or the color space isn't set right in the source files, you'll get warnings up the top there saying you've got an issue in your CPL. So we do a lot of plug festing now. We open up each other's packages all the time, and in the studio workflows we all do, we open them, and we're getting to a point now where it's actually getting really, really consistent. We don't get very many errors anymore. And that's it, because I've got a blank screen.
Thank you, Aaron. So next on stage is Matthew Pisani from Darlet. Matthew.
Hello. So today what I'm going to cover is how to manage component-based workflows, especially IMF at scale. So when you end up actually with a large number of components instead of having one single interleave file, you need a way to abstract the sophistication of this model to the users and to get the benefits of IMF, which means having those efficiencies in how you manage the storage, how you can automate the supply chain. So I will go through different use cases that show you how you see you can do that. Yes, so looking from the angle of the asset management point of view and the supply chains, whether you are using an inventory to manage your IMF assets or a transient supply chain. And you want to make sure that you get the very real promises of IMF, which means to leverage a standardized master file format, being able to optimize the delivery because you only exchange the differences, being able to reduce the storage footprint because you don't duplicate the same content, and being able to submit content at the last time in your chain. So there are two challenges or two targets. One is to convert your inventory and supply chains to something that understands component-based systems, preserving the simplicity and the flexibility for operations, including humans, and being able to maximize the automation in your workflows. So when you think about it at IMF for the first time, instead of having one single file, you end up with a large number of components, audio, video, subtitles, and an extra layer of objects that tell you that you need to use IMF packages, CPLs, OPLs, so it seems more complex when you look at it from at the first glance. How do you manage all that amount of information, especially if you end up with thousands or millions of objects in your system? So let's look first at the first logical object that you have in IMF, which is the IMF package itself. So we'll open this object, hopefully, which is at the top one. And the IMF package is the first object. It's very easy to understand. It's just a way to carry information between place A and place B. In that bucket, you can carry as many CPL as you want. You can carry different OPLs. You can carry video track files, the components, audio components, subtitles, metadata information, and sidecar. All those objects, you can put them in the bag. That's the IMF package. But you can preview. You can have multiple instances of the video, so you see exactly what you have in your package. But it does not tell you how those objects are connected together. You can put different CPLs belonging to different titles. You can have different video track files belonging to different components. It's only a way to carry information from one place to another place. So here I was just looking a way to see a delivery and what you receive from somebody or what you exported to somebody else in your system, up to the subtitle file. So now we need to look at another dimension to understand a bit more how to cope with those files. Looking at the CPL itself. A way to also understand what's happening in your system is to look at the metadata information. All the information that has been populated in the CPL, editorial information. There is a unique ID also that you understand. You see all this information easily, and it will be actionable in your asset management for search and to start also understanding the connection with the other objects. You can connect it to external registry systems like either ISAM and we automatically populate the metadata from those registries. So you can automatically look for a specific title as all the movies from a given director. And now you start to see also the connectivities with the external system and the external world. So you understand what you have, how you can search for it, how it will live in your system, in your asset management system. But what you want to understand more precisely, especially for component-based system, is the relationships between those different objects. I have a CPL. I want to know that this CPL has been delivered as part of one specific IMF package that I see here. I want to understand that actually this CPL belongs to neither an ISAN, so connected to a specific movie or episode. It is part of a logical entity that we call bundle, which is one movie, and that there are a number of track files that are used in that CPL. All this is very important because when you need to manage the purge policies, managing multiple storages, you need to understand what's going on. Here, if I expand and look at the bundle, I see all the versions that have been prepared for that bundle. I know when I click on the version, all the track files that are used in that version, and I see the rendition also that have been made. So I know now that my system understands the connections between the objects, and I have a way to automate now processes to optimize the storage, to optimize the deliveries, how I receive components, how I deliver components. You need to have something that understands this sophistication and all the power of what you can do with IMF. So now for the user, what does it mean? If I open a specific movie, that's a package that is being used for the actually DPP IMF tool. I want an easy way for a user to understand that for a movie, I have all the components that will be used, video, and I want to be able to preview, so I can have my master track file in the cloud, but I want to generate a proxy for my different video preview. I want to see if one component is expected. So I have received the supplemental, I'm missing the component. I want to be able to see all the audio track files, the stereo, the different versions of the audio. Then I want to see a view of all the CPLs belonging to my movie, and have the ability to do a quick preview of those CPL. I want to see all the OPLs that are connected to my CPL, and also give a way for users to quickly see what's going on. See the audio, the video, the markers, the subtitles, and see exactly all what has been produced by the creative people in the system. If everything is tracked properly, if I see that some components are missing for a given CPL, so I need to alert a partner or trigger a workflow for a new delivery, and that gives me a good understanding of what's going on. I can automatically trigger rendition of the CPLs, and I can see all the deliveries. I have received 2 packages that contain exactly those different components. So I see I'm in control of my system end-to-end, and I know that I can then automate tasks. I want to be able to assign a task for a user or user group, that is to review a specific version, to add some metadata, to create something, and I can automate it because I'm in control of those different objects. I get access directly to the bundle, I open the French version, I see it, I do my job on it. When I'm done, I complete the task, and that's it. And I don't see at all the complexity and all the amount of information that is connected to all those different components. Now we can start to automate the processes. If I receive multiple deliveries and multiple IMF packages, they will all be connected together because they belong to the same either ISAN. I see all the packages that belong to this. I see all the components, the original version, the supplemental versions that have been delivered to me. They've been connected together automatically. I see the different CPLs, the OV, the improvement of the OV, the supplemental version. I open each CPL and I see what has been done, the new audio track files. I can listen to the audio, I can see some inserts, and it's very easy for me to understand. And this automatic process has been done in the background, generating the proxies, connecting the metadata, extracting the metadata so that you can search for it. That's the import. I may also want to be able to create new CPLs or track files automatically from existing interleaved files that you may have in your archive, ProRes, or independent files. We can do, for instance, a simple composition where you just want to track, to stack a video track, an audio track, put the information, check that what you have in your timeline is what you expect, and easily still using the same environment, which is the bundle, which is your movie and all the versions that you need to create for it. You will put the required metadata for the CPL, also tagging the audio information for the auto track files. And what you do is simply triggering a workflow that you can configure to define the business logic that you want to automate the creation of CPLs. In many cases, you can automate the creation of new versions because you have all the business information. So you take this information, and in the background, it will find the appropriate components, do the copy if the source objects are existing valid IMF files, do the transcoding if it's required, generating the hashes, creating the IMF metadata, without having to take care about and having to be able to scale and having automated in the background. So you see the CPL, which has been generated. You can open it, do the preview in the same way as we've done before. And as the source assets were actually existing IMF components, what we've done was only pointing this CPL to existing track files. So when I look at the relationships, if I look at the track files at the bottom, those objects were the ones that are used at the beginning of the workflow to start preparing a new CPL. Now, if I need to exchange and distribute and make deliveries, it's the same. I may want to receive a work order from an external system and automate the delivery, and we can leverage all the metadata and the connections to do it. I can do it manually. I click and create an IMF package. I will pick and choose the objects that I want to export, be it CPLs, OPLs, audio track files, as easy as you can see here. And then I will trigger a workflow that will extract the information, reuse the hash values that have been stored in the MAM, automate the creation of the PKL, the asset map, and deliver that up to the final end user. So this also will happen in the background, but you can control where it will be done. So you can upload to the cloud, you can do transfer acceleration, you can use all the mechanisms and plugins and connectors that you have to connect this environment to the external of your to your existing environment itself, and you see the output of the chain. An important part of IMF is also to generate the rendition, so that you will generate the media files that will be used for playout or for delivery to the digital platforms. And again, on that, it's a workflow. So you use a business rule to trigger a workflow that will trigger the transcoding of the file. So also something that you need to automate to get the benefits of IMF in your workflows. So here I've shown a rendition. Yeah, that was the last thing I wanted to show you. So as a summary, what is very important is to be able to convert your supply chain inventory to support component-based workflows, to be able to maximize the automation while keeping it simple for the users, so abstracting the power of IMF to the user so that they can understand what's happening without losing the point. Thank you.
Thank you, Matthew. So next up is Dan Tatu from Marquise, who will give us 10 minutes. 10 minutes. On this. Okay, you've got 13 minutes.
You hear the fire alarm, it's just that the time's up for me, don't run out. We've been discussing versions, and you have to know that the original version of this presentation was 45 minutes long, so this is the short version. So I'll try to explain a couple of things in a smaller amount of time than I originally planned. All right, so this is our mastering product called MIS, for Media Ingest Stream and Transcode. It's essentially a time-based editing system that allows you to assemble content to create a master, an IMF master, but also other kinds of masters. And in this case, we're going to focus on creating a TSP 2121 master, which is the DBP or the broadcast version of IMF. We'll start with a piece of content from the BBC up there, which is a documentary and a bunch of track files, and we'll assemble that on the timeline. And as you can see, we have here a timeline with different elements. Some elements are missing on purpose. And the reason why I did this way is because the system will generate and replace the missing elements with either silence in this case, for example, for the missing audio, or actual video black for the missing elements. And of course, like with any timeline-based system, you can go through the content, preview the content, play back the audio to monitor the audio levels and verify that the actual content is exactly what you want to create. So it's an interactive system. The thing that you don't see here is that usually the setup comes with multiple screens attached for the reference display and secondary displays in the case of Dolby Vision workflows or HDR workflows, so you can fit all these screens in the video here. In terms of timeline editing, there are really quite a few things that you need to do at this stage. The classic things that people want to do is cut the material, remove elements that are unwanted. And in this exercise here, we're going to remove quite a lot of the final part of the timeline, because we want to focus on the first bits and don't want to make this thing too long. So editing is really very similar to what you're used to in your favorite editing tool, with one exception is that editing for mastering is very different from editing as in telling a story. Editing for mastering is about assembling the timeline in a very specific form so that it matches a specific delivery specification. And the elements that you see on the timeline are arranged according to this. So the number of sound fields or audio channel groups are added specifically for a certain kind of delivery. So it's not possible to mix 5.1 and stereo all together in the same track, because that's not the purpose of mastering. The reason why this is happening in mastering is because you want to isolate, like Bruce explained and my colleagues explained before, you want to isolate those components on purpose for making changes later on. So the video is frozen, or is it just me? Right, so the next thing is to set up the composition settings. So the composition settings imply a couple of things in this sort of system. So in this case, we are dealing with HDR, HLG, so one of the first things we need to do is make sure that we assign the proper HDR metadata information. So we'll first select what's called the mastering display, so the reference display that we are using to prepare this content here. And this metadata will go into the actual track files in the IMF package, and of course can be used later on for processing by different tools. So this is an important step. The color management system also allows us here to choose between 3 different systems: the native ACES, I guess you're probably familiar with that, and our own color management system. And this, of course, has an impact. If you assemble content from different sources with different color parameters that don't match with each other, that's not going to work with IMF. In IMF, every element that is lying on the same track has to share some common elements, some common metadata, as you have understood from my colleagues. And so the system here will basically allow you to put yourself into a situation where you decide what is common, and then the system will adapt the parameters from the source to what you intend to output, in this case, the color aspects. The bottom part here allows you also to select things like conversion for color space conversion, for time text, Dolby Vision parameters, which versions, HDR10 Plus and stuff like that, which is extensions to the basic IMF mastering process. So once we have this timeline here, we're happy to go to the IMF export tool. And in this tool, there's a whole list of tabs here that we can go through, and we'll essentially focus on a few of them only. The first one is the general tab, where you usually type in the name, and you have a choice between selecting the specification and an application type. So if you look at application types here, it's exactly what Bruce described before. It's the app2E, app4, app5, all these standards that have been defined within IMF that are essentially collections of parameters to constrain the IMF delivery. But these are very technical for most people, and they don't necessarily understand or even read the standards. So if you want to go that route, fine, but it means you have to understand what you're doing. Another preferred way to do these things is to do the same job through a simplified interface. So instead of having to pick all these parameters manually and make sure that they are matching the delivery, there is a better way to do it. And this way is shown in the next coming seconds, and it's based on the work that was done by the IMF user group in order to simplify this aspect. So if we switch back to the general tab, thank you, Dan. It seems I was very slow that day, sorry for that. We're going to use, instead of the application type, we're going to use the specification here. And the specification is essentially a list of templates, if you want. Here you have a list of templates with studio names, and that corresponds to the delivery specifications that each studio has. And what is behind this is essentially a configuration file that these studios define based on what they want to receive, and that configuration file drives the mastering tool, IMF generation engine, to produce exactly what the studio expects. So instead of having the user going through all the details, the mastering tool will actually fill in the blanks and prevent you from doing things that you should not be doing when delivering to a certain facility. Of course, that template file can also be used by QC systems. So for example, when the QC system receives a package that I've created according to an expected specification, the QC system can use that delivery specification to check my package against and verify what's going on, if it's all good or if it's all wrong. Next thing here is one feature that we discussed briefly here. It's the sidecar. So the sidecar is essentially a way to attach stuff to the IMF composition playlist, one or more composition playlist. Anything, movie posters, previews, QC reports, Word documents, love letters, anything you want can be attached to a CPL. It's extremely handy to be able to do that, not just focus on the actual stuff that was defined by SIMT, but be able to send other things that usually travel through email or any other sorts of unspeakable means. And then when we're done with that, we're just going to hit the encoding button or render button and get the results out into a set of files. Jumping fast forward to the version we've created, as you can see, we have some elements in here that were not present in the original timeline, and those elements were generated by our tool. It's essentially the silence that got generated automatically, and as you can see, the waveforms are completely flat, and the last part that was on purpose. And in this second part, we're going to make some changes. We want to replace this first part, and to do that, we simply insert a new element that was added. Hurry up a bit. And to create the supplemental version, we'll simply do the same thing as before. Select the specification that we want to use to prevent the system from transcoding into another specification. Fill in the metadata if the metadata is available. In this case, the BBC has some metadata that they want to the IMF package to contain. We'll select not a strategy for creating the package, differential in this case, which basically will create the supplemental package. And again, select in the output folder. The system will then look at the timeline, analyze the timeline as it goes straight for rendering, and as soon as something is different from the original version, it will either rewrap or encode the essence. That works, of course, for video, for audio, also for time text and any other sort of essence that is added on the timeline and supported by IMF. And wrapped essence is not transformed, it just gets packaged into MXF as is. When transcoding happens, it means that the source was different from what the delivery is expected to be, and then you might expect some changes. And that's really about the versioning of IMF in a very, very fast-paced demonstration. And now you can review the package here and see the content, and that's really the end of it. So I'm sorry that it's really, really fast. If you want to get the full version, 45 minutes plus the bonus, right, which is me talking 6 hours, please come and see us on our booth. You can bring Bruce with you, so you can slap him when I say bad things about IMF. Thank you very much.
And last but by no means least, Feridun with a completely different spin on IMF. So Feridun, please tell us about QC.
Thank you. Hello. So I'm taking a slightly different approach to this, but I'd like to give you a little background in terms of the kind of issues that you may be facing when you're looking at IMF and validating the issues that may happen with any IMF package. So Bruce already talked about IMF. I'll give you a very quick background in terms of the various components of IMF, such as this, CPL, PKL, and OPL. And those components are essentially XML files that are created based on guidelines that are provided by SMPTE. And the idea is to make sure these packages are properly, or these components are properly created. So we're not going to spend too much time getting in details of those particular pieces, but generally speaking, IMF as a whole, as you know, is something that is now all the studios are accepting that as their and recommending as the way of delivering content. Waiting for video to catch up. So it's preferred and recommended with major studios. It is already also being accepted by broadcasters, by the efforts of organizations like DPP who are promoting IMF for broadcasters. There's a very active and engaged user group for which Venera Technology is also part of. There are great mastering tools that we saw here that generates components, and essentially IMF is ready for prime time. So what could go wrong? Well, because of the stringent, specific, and detailed guidelines provided by SMPTE for creating these XML packages, there are opportunities and the possibilities of the package not being properly put together and components missing. So it's very important to be able to verify these XML components to be accurate, have proper data, and accurate information within them. Here are some of the samples of the issues that may go wrong with IMF. For example, the assets within a package may have duplicate IDs. The packing list, the PKL, could have duplicate entries for a given asset. There could be video audio assets missing inadvertently from the package itself. Or the PKL list could have assets that are not actually in the package. Or the CPL could have a mismatch between the audio-video metadata duration that's in the CPL versus the actual audio-video metadata values. Or the HDR metadata in the CPL could be missing. The user may expect it to be in the CPL, but it may be missing. And the hash values in the PKL, the packing list, may be different from the actual hash value of the asset. And all those mismatches could cause a problem when it comes to rendering and delivering the package. So what's the solution? To identify those and other issues in an automated way, so to reduce the risk and the resistance of delivering back with IMF. There are powerful tools out there to do the QC work. The QC work, for the QC tools to do the QC of IMF packages, exists where you work. They're either in the cloud or on-premise. So Venera has two tools, Quasar, which is for the cloud IMF validation, and Pulsar for on-premise validation to automate the process, as well as the QC of the audio and video content themselves. So the kind of validations that we potentially we do in Pulsar, for example, we can check the package structure, make sure the right elements, that the appropriate number of components that the user expects to be in the package are there. So the user can define specifically how many pieces of elements are supposed to be in the package. Package integrity. There are various checks that can automatically be done by the Pulsar or Quasar to verify that the package has all the components that it requires. CPL checks. There's a series of values that the user may want to choose to check for the CPL to make sure it's valid. Cross-checking CPL, so the information in the CPL itself against the actual package to verify those values are proper. Same with PKL, the cross-check, the hash values and the size of the assets as it's in the package versus what's in the PKL should match. OPL checks, verifying that all the components within OPL as they're expected to be are there. So all these checks can be automated. As well as integration of things like the photon from Netflix can be done within the Pulsar or Quasar package. Aside from validating the IMF package, Pulsar and Quasar can also validate the various aspects of the video and audio essence itself. So not only you can verify that the package is correct, but Pulsar can create a timeline based on what's provided as a recipe in CPL and create a logical audio video and then verify that artifacts, there are no video audio artifacts in the package itself. So whether it's loudness, audio clipping, verifying the HDR, the quality checks, other parameter checks can all be done within Pulsar and Quasar. So let's look at some actual examples and the use cases of the product. So here we're looking at three potential IMF packages. The App2 package, for example, there are the asset map, the CPL, PKL, and the vol index, as well as the three assets in there, the video asset and two audio assets in there. The RDD45 package for ProRes similarly has the asset map, has the CPL, PKL, and the vol index, as well as video and audio packets in the, assets in there. And the TSP 2121 for DPP, the package, IMF package, similarly has its components. In this case, has three different audio assets plus the video asset in the package. So these are the packages that we will be testing, verifying, validating with Pulsar. In Pulsar, you create what we call templates. Templates are a collection of checks that you want to perform on an asset. So based on the specifications for example, App2 or RDD45 or TSP2121, you can create the templates. In this case, this is the App2E template. You can the user can specify, for example, there should be two audio assets in there and all the other components, the package validation, CPL cross-check, CPL check, PKL check, making sure the hash values and the sizes match with the actual hash value and size of the assets. And the OPL checks that need to be performed. And aside from the package itself, then whatever the standards say for the guidelines for the video and audio itself, the chroma format, the bit rate, the display width and height, all those values can also be checked. The template for RDD45, similarly, you can, in the package tab, you can specify for package integrity, to validate the package, look at the CPL cross-check, CPL check itself, the various values that the user expects to be in that CPL, they can be identified. And by doing so, once the template is set, you can verify the package without the operator ever having to worry about individual packages and what needs to be checked. All the checks can be performed and set up in the template, and when the job runs automatically, it will take care of all these issues. So again, you can verify the video artifacts that the parameters that you need to verify. And finally, the last template is for the for 2121, TSP 2121 for DPP. That has its own set of guidelines. So the checks that have been set up in this template is based on the guidelines for DPP. In this case, we're checking to make sure there are 4 audio assets. As you saw in the package, there were 3, so this will result in an error. Then you can do package validation, CPL cross-check, PKL cross-check, and the rest of the checks that the user wants to perform. As well as any video parameters that need to be verified according to the TSP 2121 standards. So once you have the template set up, then to run the job, essentially the operator has to pick the package that they want to check and the template they want to check it with. So, for example, we will choose for the first package, we'll choose the App2E. So the operator grabs the package, assigns the template to it. The template has already been defined. They don't even need to know what's inside the template once it's been set. Add it to the list of jobs they want to run. Then they grab the next package they want to run, the RDD45 package, and assign it to the appropriate template. And finally, the TSP 2121 package. Grab the package, assign a template to it. And then you can run all the jobs. Once the jobs are complete, the operator can take a look at the results, So we'll look at the reports that are generated. So in this case, the Pulsar report first shows the list of the components that are in the package. Then it found some issues with PKL, so the cross-reference of the PKL hash values didn't match with the hash values from the assets. Same thing with the size, and the OPL file was missing in this particular package. It creates that CPL timeline I was telling you about. So it generates a logical video-audio timeline based on CPL, and then looks for errors, video quality errors or audio quality errors in that package. So it found some issues. The frame rate was wrong, some other issues in there. The color matrix was incorrect. All the other settings that were in the template is applied against that logical audio-video file. The other job we ran was the RTD45. In that one, again, it shows the components in the package. It creates a timeline. In this package, it found that the user had expected the max follow, max CLL for HDR metadata to be there. They were not present, so it shows there's an error. So the user is aware of what the issues are. And finally, the TSP2121 package. Again, the list of components shows. In this one, it found that the number of audio assets were the user defined as 4, there were only 3 there, so it shows you the error for that. And again, the CPL timeline of all the components that need to be put together logically to create the video audio package. I think that's pretty much it. Yeah. Thank you.
So thank you for your doing. In fact, we could give all of our speakers a big round of applause. Thank you very much. And if we could have this slide up with the Slido reference, please, that would be lovely. So I noticed that everybody was so engaged in the presentations that there is one question on Slido, but we'll come to that in a second. So this really is a session for you to find out what's in these guys' heads. So please post your questions, because if you don't, you're forced to listen to me rattle on. So I'd like to kick off just reflecting on the fact that we've seen some package creation tools. We've seen some content management tools. We've seen some QC going on. We've seen rendering of IMF packages. So pretty much we've seen everything soup to nuts, with the exception of maybe cameras and phone. Oh, I've got a phone. IMF seems to work, and one of the reasons I think it's worked well is because we've been doing this big long series of plugfests. So in a completely random order, starting with Matthias, because you're closest, just tell us how you think we've got to where we are today and how plugfests have helped.
Yeah, I think they are a great way to just find out how well everyone understands the standards, because there might be some issues that's not exactly clear what's expected.
Ambiguity in the simple standard. Ouch.
Just judging by real world scenarios. So plugfests are always great to just see everyone doing their homework and preparing stuff in advance and just find out how well it works and maybe discover things that weren't apparent before.
Yeah, Found has been at nearly all the plugfests, I think. I mean, and has anything ever surprised you? Showing up and finding things you didn't expect?
So far we have found a few things that we haven't anticipated before, but so far we seem to be on top of things so far.
Cool. Aaron, you've been at all plugfests too, and
Yeah.
often vocally.
Yeah, the plugfests have been really awesome because it's always embarrassing when you're out with a customer and you open up a package from another vendor and it doesn't quite work how it should, and it could be your fault or it could be their fault. And the plugfests have really become a collaboration, I think, where that whole finger pointing is being eliminated in the industry. And I feel like all the companies, if you're going to choose an IMF solution, make sure they're active in the plugfests. Because, you know, we just did one in London about 3 months ago. I think there was about 10 or 12 vendors there, and, you know, including QC vendors as well. And I feel really comfortable and confident that with all of the people on stage here, that we can interchange and you could take a package from here and we could add a track to it, and you could go and you could do some edits, and it will just work perfectly across all the platforms. And that's what you want in your enterprise, right? Then the other thing is, IMF's been so successful. We've seen adoption from DPP, we've seen adoption from the Academy with new formats, and there's more new things coming, of course. And so the Plugfest hasn't just been interoperability, but it's kind of been like the proving ground to me for new formats that are 80-90% ready and need 10% more feedback. And I love the fact that we as vendors and also in the Plugfest are all the major content creators are there too. So it's not just the vendors, but it's also all the content creators are there too, the studios, and even some of the people that receive the downstream content and stream it and things like that. And so it's really neat because we get to collaborate and refine those specs, and things I think are moving really fast now. It seems like we did ACES just last year. There's a new version of that coming. Going to be some archive, RDD45, where ProRes came out so fast, and at the beginning it was like, oh, another codec, another spec, and over half of the work that we're doing today is in RDD45 because
It's ProRes.
in ProRes, because if you're a ProRes shop, and you move to IMF, you don't have to transcode it. You can just rewrap it in XF, and so all the libraries you have, you don't have to retranscode them, you just rewrap them. And so it's a beautiful thing, and it makes it component-based video. So the evolution is getting faster and faster, I think, from the Plugfest.
Matthew, I mean, as a man, I was just going to say, as a man guy, there's, in the early days, there were the questions, why is the man guy here?
So, I wanted to add that there are two great things about the Plugfest. One is also just seeing that the standard, the IMF framework is evolving, it's live, and there are many contributors, and it will evolve on so it's a good sign that there are really interest in that framework. It's a good place for discussions also about the workflows themselves. So as soon as you start discussing about components, you need to start about workflows. What does it mean, and what is the end-to-end workflow? How to have the benefits of component-based workflow? And that's where MAM has a lot of sense because it's a helper to track what's going on in your facility.
And also, you're more from the TV end rather than the movie end.
Yes,
so, because I remember the early days, there was some TV. Why are you here?
Yeah. Also, I think that's a very good point. Is also we see IMF as a kind of catalyzer, and when you start putting IMF in the workflow, again on that, if you want to get the benefits, you need to have the full chain. So it starts to connect to different areas of the supply chain, from the distribution side, but going back to also touching the broadcast industry, up to the studios. So it's quite interesting that we see now the boundaries between the different previous verticals in the supply chain, I would say, are getting blurred now. It's quite exciting.
Dan, you've been at every Plugfest without exception, I think.
I'm sleeping there.
A little cot in the corner. How's it affected your product?
Plugfests have been really fantastic, but I think we've passed over the technical challenges, which we pretty much all of us here cover well for a while now, and we entered into a world where IMF is tested against users. We have a lot of people at these Plugfests, especially those who produce the test vectors of the Plugfests are based on exercises that are given to vendors by IMF users, right? People who actually work with the content. And they went from a very basic IMF package, a simple CPL that only has one video element and one audio element, to something that starts to resemble what they want to work with now and in the future. And the thing that the Plugfest in October was very interesting, that one of the problems that we had there had nothing to do with IMF. The problem was, are we editing this element on the frame before or on the frame after? It was very interesting to see that. And the reason why I wanted to mention this is because this is exactly where we want to go with IMF. We want to break content into components so you can replace them, localize content for various areas. And we are finally confronting the technology to how people use it. And there we have a new challenge, because it has nothing to do with 70 labels. It has to do with practices for working with component-based media and standards. And Plugfests are also really good for that too. It's not just about bits and bytes, I think.
Yeah, I mean, the conversations we have in the Plugfests, I think, push the standard and the working practices forwards like no other cohort that I've seen. Feridun, you're a QC vendor. Who
Yes.
keeps you honest? Who QCs the QC? Do the Plugfests help?
It actually has made a huge difference for us. The reason we have been able to get in so much depth of doing the validation QC is active participation in Plugfest. We read the specs, we can start writing the validations based on what we can spec, but interactions with Dan and everyone, Aaron and everyone else, gives us a chance to really talk through those specs. And sometimes what's said and what's really actually meant is slightly different, and so that has allowed us to really dig deep and then be able to provide, because a lot of the users want that sanity check, even though these products all do a great job, but you still want someone else to independently verify that these things are right. And then there's no better way than for me to be able to, for Aaron to say my stuff is right, and for me to say, oh yeah, it is right, or I found this thing or not, and then be able to validate. And we've gone back ourselves multiple times. We found error, showed it, Dan says no, it's not an error. So we go over and talk about, oh yeah, you're right. So we go back. So as a result, it makes all of our products that much better and more so.
So one of the messages here is that one of the reasons IMF's trusted is because it's tested. In fact, it's tested to death. And strangely, Matthias touched on it, but sometimes their standard's not right. I think I saw Florian in the room somewhere. So Florian heads up one of the groups within SMPTE where we're using software methodologies to fix the standard. So heaven forbid that there might be a problem in a SMPTE document, as if that would ever happen. But we log these issues, and we then start to drill into them to find out, is this what I call a picnic error, the problem in chair, not in computer? Is it just misreading of the spec? Is the spec generally a problem? Or is there something that generally needs to be fixed? And what I found really fascinating is that you've got all of these experts in the area studying the words on the page and looking at the implementation in the product. And we've just had an experience within SMPTE where we thought there was a problem with the document, and this big long conversation started in this big long circle going, yeah, we're going to change it like this, no, we'll change it like that, no, we'll make it better, we'll add more words, we'll delete some words. Oh, actually, there are no better words than the words that are currently there. And, the end users of these standards never get to see that process. But we literally go through every dot, every comma, every verb, and just to make certain that what we've written down is really the way that we want to work. And if you're getting into IMF, and you're not part of that group, then you don't have a say. So one of the messages here is if you're want to be part of IMF, whether it's personally or part of your business, then joining the IMF users group or getting involved in SMPTE or just showing up at the Plugfest with a big hot pot of coffee and wandering around all the tired-looking people and keeping them awake, you will learn more that way than you ever will listening to any of my tutorials. Actually, that wasn't a good sales pitch, was it? But one of the things you will have seen here is that there's a lot of flexibility in IMF. So how do we write down the sort of IMF we want? I mean, Dan, is there any way that we could, come up with some sort of language for a delivery specification for IMF? Is that a possible thing?
Well, anything's possible if you want to achieve the goal, right? It's just a matter of will. And I'm really happy to say that the user group is not just a bunch of people who got together on Friday afternoons to have coffee and
beer.
Crack jokes, and beer eventually. The user group is a lot of talented people coming from different areas, vendors obviously, but also studios and standards people. So the user group is the interaction of these three different worlds. And people there have established working groups, and they work on different topics. One of the topics was led by Bruce regarding the time code in IMF. How do we use that? Do we use this in IMF or not? And what are the good and bad practices? And then over time, we developed a new group, which is focusing on the delivery specifications. So it's probably something that seems easy for you, but delivery specifications are usually coming as PDF or Word documents in your mailbox. And somebody in your facility has to read those and translate them into a file at some point.
And does that ever go wrong?
Well, the problem is that the people who write the actual specifications are not necessarily using any tool that creates the files, or do not even understand the technical terms they use. The nicest I had to read recently was that somebody mandated the use of the H.266 codec, which is still under development, but that's the kind of thing that you find there. So, of course, when you look at IMF, and we all try to present it here in a way that it's pleasing and simple, but as Mathieu said, there's a lot of complexity that is managed, beneath. And how do you make these two things work together, simplicity and complexity? Because IMF is also very good at handling complexity. And the IMF user group has established a working group who developed what's called the IMF delivery schema, which is essentially an XML version of these delivery specifications. So instead of having people sending you PDF and Word documents, they can publish an XML file. The good thing about this XML file is that it's displayable and readable by a human being, but also computers and software understand that all of the products that you have here on stage read and understand that, and others who are not with us right now. So this allows somebody who wants to publish a delivery specification to send a very precise description of the delivery to all the products that support IMF,
So,
including QC.
So Matthias, Aaron, and imagine that if, for example, you had an IMF product. I know it's a hard imagination thing. Does this help? Does this get rid of some of the randomness, Matthias?
Of course, if you just eliminate misunderstandings possible just by people phrasing the same thing differently, that really helps. And so I'm all for it.
Yeah, and I think one of the cool things is the QC vendors and other vendors in the supply chain that interact with that workflow can all read the same source of truth. So imagine you build the package to the specification, but the QC product, instead of having a template, it reads a specification that's been defined and it QCs against the specification, not against the template that a human set up that may be missing some of those values. And so I see it as just more quality control and more automation that keeps evolving.
It's almost like joined up thinking. In this industry, that's pretty novel.
There's one interesting thing that Ferlud said here. It was very brief, but for some people, some things are errors. For some others, they are warnings. For some others, it's just random information. And of course, in standard, this sort of thing is not always clearly defined on purpose because interpretation is left to different parties. With the user group working on the delivery schema, we're trying to fix these things so people can say, hey, this is an error for me. So if it's not there, it's wrong. And some others can say, this is a warning for me. And that's really important to make the workflow actually work.
Yeah.
So we've got about 6 minutes.
Yeah.
We've got 3 questions. So I just want to leap in with one for Matthew, which is identifiers. So we've talked a little bit about CPL IDs. Can you talk through a little bit about how tracking of registered identifiers like IDA and ISAN relates to the management of content and how IMF helps or hinders that?
Yes, so it's a good question, and it's about metadata and tracking of all the objects. So if you understood, for IMF, every single component has a unique ID. The CPL is also making the aggregation, is using those different components, so also using the unique IDs. But if you want to go one level up, so aggregating all the CPLs together, the only way, or the good way to do it, is to leverage the content version list, which is another set of IDs which opens the world of IMF to external registries, which can be your own registries or official ones like IDA, ISAN. And when you have that layer of metadata, then really you can aggregate and consolidate this information and also bring back editorial information inside your IMF workflows. So it's really important to connect the IMF workflows to your own business editorial workflow where you track the work orders, requesting for a specific content. So that's really a key contact point between the IMF supply chain and your existing workflow and business systems in your facility.
Excellent. Anybody else want to add anything to IDs? In that case,
well, I do want to add that people should really start to use those IDs and probably even abuse them, because what IMF has showed us, and through the plug, but also through the various discussions we had, is that these components are literally flying around the planet these days through cloud systems or on-premise systems. If you think about it, after 5 minutes, without having proper identifiers to tell you where this is located, where it comes from, who created this, it's going to get messy very quickly. So working with identifiers for versions for the content It's a practice that unfortunately only exists with big studios at the moment because they have an interest to do that. But for smaller facilities, it's not yet in practice, and I really encourage people to look at this and adopt this sort of practice.
We'll do a quick ask to the audience here. Raise your hand if you've ever lost a file on your computer. Okay, everyone, leave your hand up if you later discovered that you lost the file because you mistyped the file name. Yeah, all of you, I know. You can't deny it. So this is why we don't use file names, especially when somebody tries to make a workflow work by, I'll just change this file name and see if I can get the workflow to work properly. I'm sure nobody in this room would do this, but all those people that work for you, just sack them all. So the next question, which should be a quick one, is Netflix has been one of the big promoters of IMF, and it's like, does your stuff go into Netflix? So does everyone here support the Netflix delivery spec? Just nod if you're there, good, excellent. So the one that I want to end on, which is more of a debate really, is the question is there a security framework for IMF?
I can quickly answer to that. There is provision for that. IMF can be secured very much in the same ways as DCPs are, for example. So you can encrypt, but private and public key mechanism, the essence and the assets. So this is really possible to do. The major difference between digital cinema, for example, and IMF is that IMF is a business-to-business relationship, right? So the security is essentially based on the contracts that people have between them. And if things go wrong, you end up in court or jail, depending on what you did wrong. With digital cinema, the situation was a bit different. It was really how do you establish a secure relationship between two different ecosystem people who actually own the content and projectionists who have no relationship with the studio. And so you needed to have a key mechanism to control for how long a feature is displayed on screen. So IMF has the possibility to handle security. For now, I have not seen a great motivation to incorporate that because, of course, when you add a layer of security, you also add a new layer of administrative tasks. So maybe in the future, but it's definitely possible.
So Aaron, I mean, you're an MPAA authorized user. How do you cope with that security framework?
And TPN as well,
TPN.
which is the new sort of version of the security model for cloud. Well, there's a couple of things there. I just want to mention hashes because we didn't really talk about them much, but all the essences, so all of the tracks, have checksums. And you create those checksums, and the CPLs reference the checksums. And so you always know, it's the first thing that any of our softwares will do, is when they open a CPL is they check the checksums, so you know if you actually have the right files in the folder that you're supposed to have. So the system is kind of self-healing from that perspective. It's not really security, it's more of a consistency system. But that checksum methodology actually works very, very well. From more of a security perspective, and you know, a lot of the things that we have to check from a QC perspective are quite different when you're in the cloud because you might have every file for your company visible to you and accessible. So if you had a duplicate UUID or you had security areas with different levels of security when you open those CPLs and you can't find those resources and things, a lot of it gets eliminated when you can see all of your files, right? And you have access to all of your files. Our customers actually own their own buckets and their own security, and our software gets permission to go into their bucket, work on their files, and then come back out again. And so for security in our platform, we actually never store the video in our cloud, and we just run it in and out of our customer storage. And so they can put on the policies, the auditing, and they literally could come and say, this is a new original feature, we're a little paranoid about it, we're gonna open up this bucket to this server for this many hours to process and put the Dolby Vision in there and package it up to send it, and we're gonna shut it down.
And we're out of time.
Yep.
So that's it, folks. Please give us some feedback to the IMF users group. You can find us online at imfug.com. I'd like you to put your hands together and thank our panelists for all their presentations. Thank you very much, everyone.